That is sleep apnea is one of the few things that can artificially, reliably, dramatically reduce your slow wave deep sleep, because it prevents you, because you can't detach, because your bodies keep trying to get your attention. The other thing it does is it can dramatically increase stage one. And it can also, because your sleep is more shallow and you have more of these arousals and awakenings, even if you don't wake up all the way, your brain is still sort of moving around. The other thing it can do, it can dramatically reduce your REM sleep. Because remember what I said about muscles and REM sleep? Even your respiratory muscles get weaker. That's why snoring is worse in REM, or worse at the end of the night, because you have more REM at the end of the night. So if you're already in a floppy tube, trying to breathe out of this floppy tube that's already having an issue, and then you make the muscles go extra limp, snoring's going to get worse. So you're going to have more awakenings out of REM. You're going to have less deep sleep, and your sleep's just going to be more shallow overall. So that's why people with sleep apnea, they wake up and they feel like, it's sort of like, I just ate a whole meal and I'm still hungry.
Right.
Untreated sleep apnea is a known risk factor for neurodegeneration, especially when it's more severe. You can still get cell death, and you can get neuronal problems, because think of it this way. Every time you have one of these respiratory events and you're having it, maybe dozens of times per hour in the night, your oxygen drops. And it's not the hypoxia that's the problem. This is what a lot of people get wrong about sleep apnea. It's not really the hypoxia. It's the intermittent hypoxia. So you're not hypoxic, because what will happen is you drop a few points. Most people, unless you have some other lung disease, most people with sleep apnea, their O2 doesn't drop a lot for sustained amounts of time, unless you have like emphysema or something. It'll drop a few percentage points, then your body wakes up and then it recovers. Then it drops again. Then your body wakes up and it recovers and it drops. So it's like, it's constantly putting out all these little fires all over the place. The fires are never burning any houses down. They're just sprouting up all over the place. But what ends up happening is, all of these cells are releasing reactive oxygen species every time this happens. So you're releasing these reactive oxygen species, this oxidative stress is happening, and then it's quelled. And then it's stressed, and then it's quelled. And then it's stressed, and then it's quelled. And it's stressed, then it's all night, for days, or months, or years, or decades usually. Imagine the stress, like your cells are trying to do their job, and they're constantly dealing with all this nonsense. Instead, imagine trying to do your job and you're constantly having to do all this other stuff. So you're not getting the recovery function that that you were built for.